Here I have an equation which is 2x plus 3y minus 9 equals to 0. Above that I have written the general equation which is ax plus by plus c equals to 0. But in this case you must be observing that I have written 1 in these places, that is a1x plus b1y plus c1 equals to 0. It only means that I'm just talking about one equation in this pair of linear equation. So if I take another equation over here, 4x plus 6y minus 18 is equal to 0, I will have the general equation as a2x plus b2y plus c2 is equal to 0. A pair of linear equations, right? So one equation, two equations. 2x plus 3y minus 9 equals to 0. Let me draw one line over here. Now, the second equation will be forming another line. So, there are three basic possibilities that can happen. Either the second line might intersect the first one, or they might be parallel to each other, or the third case is they are exactly overlapping on top of each other. So these three things are possible. Now every time when two equations are written, it is impossible to directly look at it and tell what kind of situation will form. Either the lines will intersect each other, or they will be parallel to each other, or they will overlap on each other. The values of a1. Now if you look in this case, a1 is 2. Similarly upon a2, which is 4. So I will get something like 2 upon 4. Now I will look at b1 and b2. So b1 is over here, which is 3, and b2 is 6. Same way, c is it 9 or minus 9? I'm sure by now you know it is minus 9 upon minus 18. Now, in case these ratios are equal, so which is, if I cancel 2 1s are 2 and 2 2s are 4, 3 1s are 3, 3 2s are 6, and 9 1s are 9, 9 2s are 18. So here my ratio a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Now when this condition is satisfied, we get coincident lines which has infinitely many solutions. Now coincident, which means the first line and the second line are exactly on top of each other. That's the reason you get infinitely many solutions. So what is the condition? Condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, which is called as condition for coincident lines. And you will get, if you solve these two equations together, you will get infinitely many solutions. Now here I have another equation which is x plus 2y minus 4 equals to 0. Here again I have written a1 x plus b1y plus c1 is equal to 0, and it is only because it is my first equation. Similarly, I have another equation which is 2x plus 4y minus 12 equals to 0. Since it is my second equation, I have written over here a2x plus b2y plus c2 is equal to 0. Now, based on this, we will check what is the next condition. It is for parallel lines and you get no solution. Now, here the condition is somewhat like this. a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Now, here my lines are going to be parallel to each other. Okay, so since they're not going to touch each other at any point, you are not going to get a solution. That's the reason it is said as no solution. That solution, what we are trying to tell, is that point where both these lines will meet somewhere. Now, since they are parallel lines, they are not going to meet anywhere. That's the reason it is the condition is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. So let us just check whether it is possible in this equation or no. Okay, so here my a1 is 1, a2 is 2, b1 is 2, b2 is 4, c1 is minus 4 and c2 is minus 12. So I can't further divide this, but I can do over here, which will be 2 1 and 2 2s are 4 and 4 1s are 4 3s are negative and negative cancel. So here I will have a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. But here you have, because you're having 1 upon 3 as the other ratio. So the condition for parallel lines is here a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Here another equation, it is x minus 2y equals to 0. So I have taken the general equation. 1 I told you is because the first, this is my second equation, so it is 3x plus 4y minus 20 is equal to 0. So here what are we going to do is we'll see what is the condition for the next line, that is intersecting lines. If two lines are intersecting each other, okay, if two lines are going to intersect each other, then you are going to have this condition will be satisfied. So let us check whether it is possible or not. Here my a1 is 1 upon a2 is 3, b1 is minus 2 upon b2 is 4. So if I cancel this 2 1s, 2 2s, so 1 upon 3 is not equal to 1 upon minus 1 upon 2. That's the reason you will get intersecting lines and it has exactly one solution, which is called as a unique solution. You don't have many solutions for it, you just have one solution, because this line is going to intersect only at this point. Because this line is going to intersect only at this point, nowhere else. So you are going to have only this and only this solution. Whereas in the first case, when we were looking at two lines overlapping, there are so many places where the line is touching. So it is going to give you infinitely many solutions. In this case, it is unique solution because it is going to cut only at one point.